Hello everyone. Question 6 is about topic 7, geometrical optics, whereby we deal with light. So, this is the equations we are going to use under topic 7, starting from equation 66 until 70. To solve any problem about geometrical optics, we have to be careful with the use of the equations. When we use the equation given, we have to include the sign conventions depending on our problem is about mirror, refraction at spherical surface, or thin lens. They have the different sign conventions. Okay, so bear in mind, equation 66 is only used for mirror. Equation 67 and 68, 1 over f is 1 over u plus 1 over v, and the equations used to determine magnifications can be used for both mirror and lens. And equation 69 is the spatial equations that we use to determine the image distance for refraction at spherical surface. For example, like we observe the image of a fish in water. Okay. Then equation 70 is only used for thin lens, whereby we use equation 70 to determine the focal length for a thin lens. Okay, so please be careful. Never ever mix up in between equation 66 for mirror and equation 70 for thin lens. Okay, for mirror, we only have one spherical surface, so we only have one R. But for thin lens is combination of two spherical surface. We have first spherical surface R1 and second spherical surface R2. So for thin lens, in order to find the focal length, we have to use equation 70. That one is only for lens. But in order to find focal length for a mirror, spherical mirror, we are going to use equation 66. Okay, so do not mix up equation 66 with 70. Again, I remind you, in order to solve any problem in geometrical optics, the first step when you read the question, you have to identify whether the problem is about mirror, refraction spherical surface, or thin lens. Then only you can go for the correct sign convention. Okay, the sign convention will be different for mirror and also thin lens and spherical surface. Then we proceed to the discussion of question 6 in our mock set 5. So question 6a, a boy standing 4 meters from a mirror sees his upright image with a magnification of 0.2. Determine the radius of curvature and the type of the mirror. So we want to find the radius of curvature R for the mirror and the type of the mirror. It means that our mirror is concave or convex. Okay, so the boy is the object. The boy is our object, is standing 4 meters from the mirror. So the 4 meters is the distance of the object from the mirror. So we understood our U is 4 meters. And see his upright image. So upright image must be a virtual image whereby the image is formed behind the mirror with the magnifications of 0.2. So the magnifications will be positive 0.2. If we refer to the sign conventions, magnifications, upright image, the magnifications is positive. So our M should be positive 0.2. So we want to determine the R and the type of mirror. So if we refer to the equations given, in order to find for the radius of curvature, we have to know the value of focal length for the mirror. So this focal length of the mirror can relate with the object distance and image distance. So for this question, I know about the object distance, but then I didn't know about the image distance. So how I'm going to find the image distance to solve the questions? Okay, we can determine the image distance from the magnifications. So I start with equation 68. So magnifications is negative V over U. So our magnifications is positive 0.2. Negative V over our object distance is 4. So I'll get my image distance will be negative 0.8 meter. So once I get the image distance, I can determine the focal length. The focal length will be 1 over U plus 1 over V. We use equation 67. So 1 over F will be 1 over 4 plus 1 over negative 0.8. So be careful. Always include the negatives, the sign convention. Do not let out the negative during the substitution. So we can determine the focal length. So I get the focal length is negative 1 meter. So once I get the focal length, then I can relate the focal length with the radius of curvature using equation 66. So I put it here. So the R radius of curvature for the mirror will be 2 times of focal length. So 2 times negative 1. So include the sign convention. Okay, include the negative in your substitution. So you will get the radius of curvature is negative 2 meter. So what is the type of the mirror? How I'm going to know the type of the mirror? So I might refer to the positive or negative value I get in my answer. So if we refer to the sign convention, R negative for mirror is convex. Okay, so R negative for mirror is convex. It means our mirror is a convex mirror. So since the R is negative, thus the mirror is convex mirror. So it's a convex mirror. So this one will be our answer for the radius of curvature and also the type of the mirror. Now we move on to question B. An object is placed 14 cm from a diverging lens of refractive index 1.5. So the material we use to make the lens is 1.5 and the radius of curvature for the lens is 4 cm and 7 cm respectively as shown in figure 6. So sketch a ray diagram to show the formation of the image. Number 2, calculate the image distance. So image distance is represented by B, so we want to determine the value of B. So first question, I need to sketch a ray diagram, so I will draw the diagram object. So the object is around 14 cm in front of the diverging lens. Anyhow, in order to sketch the ray diagram, I need another information, which is the focal length. So that I can put my focal point for the diverging lens. So before I can sketch the ray diagram, I need to calculate the focal length of the lens, of this diverging lens. So since the question gives us the radius of curvature for the lens, so I can determine the focal length by using lens method equation 70. So I have 1 over F is N material over N medium minus 1 over R1 minus 1 over R2. Now I put in the value, so the refractive index of the material, the lens is 1.5. This lens is put in A, so the mediums is 1. And then I'm going to put in the R1 and R2, but then in order to substitute the R1 and R2, we have to include the sign conventions. So if we refer to the sign conventions for thin lens, R and F is positive for convex surface, and for concave surface, R and F is negative. So how I'm going to determine whether R1 and R2 is positive or negative? So I have to check whether the surface is convex or concave. So the light ray is always from the front side. So seen from front side, when the light ray strike on the first surface, the surface is curve inward. It's a concave surface. So our R1 will be negative. Same goes for R2. When the light rays strike on the second surface, the surface is curved inward. So R2 is also concave surface. The R will be negative. So I put in the value. So it will be 1 over negative 4 minus 1 over negative 7. So when I do my calculations, I will get the focal length is around negative 18.67 centimeter. Okay, so I have get the focal length, then I can put the focal point on my ray diagram. So my object is 14 cm from the lens, so my focal length is 18. So my focal length will be behind the object. So let's say my focal point is here. Okay, my focal point will be here. So then I can start to sketch my ray diagram. So first ray start from object parallel to the principal axis. At its strike on the lens, it will be diverge from the focal point. Okay, it seems to be diverged from focal point. So it will seems to be diverged from focal point. Okay, it will be seems to diverge from focal point. Okay, this olah diverge from the focal point because we are having diverging lens. And then the second ray we can draw start from the object and then go straight, passing through the center of the lens. Okay, passing through the center of the lens. Then we are going to get the intercept. The intersections of these two rays will be the position of the image. So I label it as I. So we need to label it as the position of image. So I label as I. Okay, so this is our ray diagram. Then question 2, we need to calculate the image distance. What is the image distance? How far is the image formed from the lens? So I'm going to use equations 67. So I have 1 over f equal to 1 over u plus 1 over v. So 1 over v will be 1 over f minus 1 over u. So putting the value 1 over, our focal length is negative 18.67 minus 1 over, our object distance is 14 cm. Then we do our calculation, we will get the image distance will be negative 8 centimeter. Okay, now we solve question B.